The theories of relativity developed by Einstein are considered to be the most prominent and widely accepted theories in physics today. Relativity has been subjected to many tests, and people generally believe that it has passed all the tests. Meanwhile, many scientists are still working to find any possible errors in this line of thinking. Each test will be discussed in detail later. Relativity has two parts, special and general. The special theory discusses the relationship between space and time. It explains how velocity affects mass, time, and space. According to special theory, matter and energy are different manifestations of the same thing. The equation E equals mc squared, where E is the energy, m is the mass, and c is the speed of light, describes this matter-energy relationship. The theory states that the speed of light in vacuum is the same for all observers, regardless of the motion of the light source or the observer. Today it is also believed that the light speed is a universal constant. The general theory of relativity is the geometric theory of gravitation published by Einstein in 1915. The basic idea is that instead of being an invisible force that attracts objects to one another, gravity is a curving of space. The more massive an object, the more it curves the space around it. Maxwell's theory of electromagnetic waves and the negative result obtained from Michelson-Morley's experiment were the main factors that led Einstein to develop the theory of relativity. Earlier it was believed that there was a substance called ether that filled space, so it was thought that the motion of the Earth through space could create an ether wind against the motion of the Earth. Michelson and Morley, two experimental physicists, devised an interferometer set up to observe the relative motion between the Earth and the ether. They measured the speed of light in different directions, but the light speed was the same in all directions. From this result, they came to the conclusion that there is no such thing as ether. The scientific community took the Michelson-Morley experiment seriously, and it resulted in the complete rejection of the ether concept. In fact, Einstein's theories of relativity were developed mainly based on the idea of the absolute speed of light, the constancy of the speed of light, and the result of Michelson-Morley's experiment. Hence, any inconsistency with even one of these will have a negative impact on the theories of relativity. Footnotes. Regarding the idea that the speed of light is absolute. This idea has any significance only if the light is a particle. In fact, if we find a better explanation for what is light and how it propagates, then there is nothing special in this notion of light. For example, if the light is shown to require a medium for propagation, or the propagation of light involves some substance that fills space. Meanwhile, my studies indicate that photons are not particles, but rather bundles of vibrating magnetic lines traveling through space at the speed of light. The constancy of the speed of light. To justify this idea, Einstein suggested that space near a mass is curved and bends light. According to Einstein, gravity is the curvature of space-time. Therefore, near a massive body, light travels an extra distance to keep its speed constant. But these concepts have relevance only if space is empty, as Michelson-Morley's experiment suggested. But my studies indicate that the space-filling ether exists, and that helps to understand phenomena like gravitational bending of light, time dilation, etc. In fact, according to my study, the speed of light is not the same throughout the universe. Einstein's explanation of gravity. The tidal movements of water and land mass show the pulling effect of gravity. The moon is actually tidally locked with the Earth, which is why the moon keeps the same face to the Earth. The Earth does wobble on its orbit due to the moon's gravity. Since its large mass, the Jupiter has a similar effect on the Sun. These show the gravitational force of attraction, or the pulling of gravity. Therefore, the notion that gravity is a curvature in space-time is questionable. As we saw above, if there is a space-filling substance and if gravity can create a dense region out of this substance, the light will slow down when it enters such regions. This provides new insight into the curved space-time.